Okay, we're back with the next two problems, 11 and 12. See, we can get through these in about 20 minutes too. By the way, the on the real AP test, a free response question, which might be somewhere similar to this in length, you're going to have about 15 minutes for each one of those. So we're going at about 10 minutes per each, so that's a good clip. If you're going a little slower than that, that's absolutely okie dokie. So here we go. Consider the curve here. They want us to show that the derivative is this, similar to part A of the last one. So let's take the derivative and see if we can get it to look like that. Derivative of x squared is 2x. Derivative of 6x is 6. The derivative of y cubed is 3y squared dy dx. Please don't forget this. The derivative of 12y is 12 dy dx equals the derivative of 11 is 0. And we factor the dy dx off those two terms. Times 3y squared minus 12. And we move the other two pieces to the other side. It'll be 6 minus 2x. And we divide by this. And sure enough, we get what we were supposed to get. Right? Implicit differentiation. This is the kind of problem that this really does show up on the AP test, where they say first part of a problem is show that that's the derivative. It really does happen. Write an equation for the tangent line to the curve at the point 6, -1. Well, they're giving us the point. That's nice. All we need is the slope. And we've got our slope formula right here. So m is equal to 6 minus 2x over 3y squared minus 12. That's 6 minus 12 over 3 minus 12, which is 2/3. So y minus y is equal to m times x minus x. Hooray for point-slope form. Next part. Find the coordinates of all points on the curve where the tangent line to the curve is vertical. Well, what would make the tangent line vertical? For it to be vertical, dy dx must be undefined, or in other words, equal to a number over 0, right? That's how we get vertical tangent lines. Lots of rise, no run, right? Straight up and down. So unlike our horizontal ones, instead of setting the top equal to 0, now we want the bottom to be equal to 0. So this means the bottom's got to be equal to 0. So we're looking at 3y squared minus 12 equals 0. That gives us y squared is equal to 4. Y is equal to plus or minus 2. Now they want the actual points on the curve. These are just the y values. How do we get the points? We have to go back to the original here. So let's see if we can find the x values that go with these y values. I'll do the 2 first. For y equals 2, we have, let's see, I have x squared minus 6x plus 2 cubed minus 12 times 2 equals 11. Right, I'm just plugging the y equals 2 in there so I can solve for x. So that gives me x squared minus 6x. Let's get everything together on this side. That's 8 minus 24 is minus 16. Minus 11 is minus 27 equals 0. And that looks like it might have a chance of factoring, so x, that'd be a minus 9 plus 3 they do expect that you know Algebra 2 and that you do not have to struggle with this. If you do struggle with this, you need to practice that because you should have learned how to do it well a long time ago. So that gives us x equals 9 and negative 3. So look, that's interesting. For this y value, I got two different x values. But remember, for these implicit things, this is not necessarily a function, right? It's got a y cubed and a y in it. So I got 2 points here. I get the point negative 3, 2. That's one of the x values that goes with that. And the point 9, 2. There's a couple of points. That's only for plugging in y equals 2. Now what about plugging in y equals negative 2? Let's try that. So for y equals negative 2, I get x squared minus 6x plus negative 2 cubed minus 12 times negative 2 equals 11. And let's clean that up. Let's see, x squared minus 6x, that's minus 8 plus 24 is positive 16 minus 11 plus 5 equals 0. And at this point, I applaud the person who came up with this problem because they created this so both of these things factor. That's pretty awesome. And so that gives me, again, two x values. Good job, Stu Schwartz. There he is. And so that's 1 comma, these are the ones that go with the y values, negative 2, and 5, negative 2. So I challenge you right now to go to Wolfram Alpha or some other type computer algebra system that will graph this for you and take a look at whatever this crazy thing looks like and see if in fact it has vertical tangent lines at these 4 points. I dare you. You can't do it with your calculator because you can't graph that with your calculator. But go to Wolfram Alpha, type that in, see what happens. You'll be smarter for it. Show that it is impossible for this curve to have a horizontal tangent line along the line y equals 4. Well, what does that mean? Well, if it's going to have a horizontal tangent line at y equals 4, of course the y coordinate would actually have to be 4. So the first thing I think we should do is plug y equals 4, plug 4 in for the y value in the original function and see where that leads us. Alright, so doing that, I have x squared minus 6x plus 4 cubed minus 12 times 4 equals 11. And let's see what happens here. So that's x squared minus 6x. 4 cubed is 64 minus 48 is 16 minus 11 is 5. Again? Did that really just happen? I think it did. And that means the x coordinates, when y equals 4, x could be, sorry, I should factor that first. That's x minus 5, x minus 1. X could be either 1 or 5. Right? So we're talking about the points 1, 4, and 5, 4. Right? Those are 2 points that are on the curve and where the y coordinate's 4. And now I think all we need to do is plug those back into the slope and see if it's horizontal or not. So let's try to find dy dx at this one. So here, at this point, dy dx would be equal to 6 minus 2 times 1 over, well listen, we're looking for horizontal tangent lines. I mean, it hardly even matters what the bottom's equal to, right? Because if it was going to be horizontal, it would have to be equal to 0. That would mean the top would have to be 0. And 6 minus 2 times 1 is not 0. It's 4. And then if you want to just finish this thought, that's 48 minus that's 36. So the slope there would be 1/9. So pretty flat, but not 0. And then likewise at 5/4, dy dx would be 6 minus 2 times 5. Again, that's negative 4, so not happening. Or 3 times same y value. So that came out to be a slope of negative 1/9. So at y equals 4, when y equals 4, we do get 2 points on the curve, 1, 4, and 5, 4, but they don't. Neither one of those has a slope of 0. So no dice. And that's what they wanted us to show. Okay, this is a similar problem. First step, like the last one, we just want to show that this is the derivative. So the derivative here, this is 4x minus, careful here, we got to use the product rule. The derivative of the first is 1 times the second plus the first times the derivative of the second. I like to treat that like its own little thing. That helps me avoid making sign mistakes. 3y squared dy dx plus 1 equals 0. And then let's see if we can clean that up. So the two terms with the dy dx in them, it's dy dx times this, factor the 3y squared off that, have a minus x times the dy dx. Then we'll move all the other terms to the other side, and we'll do it in this order. So let's see. I'll add the y over there. I'll subtract the 4x. This kind of guides us, right? And subtract the 1. And then sure enough, dy dx is equal to y minus 4x minus 1 over 3y squared minus x. No sweat. Find all equations of all tangent lines to the curve at y equals 1. All right. So let's see. This is similar to the last part of the last one. So if we plug y equals 1 into this, let's see what points we get. And that'll tell us how many we have to find. So plugging y in here, that gives me 2x squared. I'll write it like I did the last one. At y equals 1, we have 2x squared minus x times 1 plus 1 cubed plus x equals 9. That's 2x squared minus x plus x. Those cancel out. And I have a 1 minus 9, that's minus 8, equals 0. X squared equals 4. X is plus or minus 2. So looks like I've got two different tangent lines to find. One is at the point 2, 1, right? Remember these were when y equals 1. And the other one is for the point negative 2, 1. So again, whatever this thing is, it's not a function because it's failing the vertical line test right here. Got two different x values giving us the same. Well, oh no, sorry, that's not a fail, is it? That's two different x values going with the same y. So probably this isn't a function, but not for that reason. Okay, now we need to find our slopes. So slope is equal to what we get when we plug 2, 1 into the derivative, which we have right here. That'd be 1, right, y, minus 4 times x minus 1 over 3 times y squared minus x. And that's negative 8 over 3 minus 2 is 1. Well, that's negative 8. So my line is y minus y equals m times x minus x. There's tangent line number 1. Didn't leave myself a whole lot of room here. Let's see if we can squeeze it in. So m for this one is equal to y minus 4 times x minus 1 over 3 times y squared minus x. So that's 8 over 3 plus 2 is 5. So that's y minus y is equal to 8/5 times x minus x, right? Two minuses make plus. There's my two tangent lines. Alrighty. Now, part C. There's a number k so that the point 2.1 comma k is on the curve. Using the tangent line found in part B, approximate the value of k. Well, this is a number that's close to 2, right? So that means instead of plugging 2.1 into the original function, we could plug 2.1 into this tangent line. So k should be approximately equal to what we get when we plug 2.1 into the tangent line, because we're close to 2. So that would be, I'm just going to move this to the other side, just like we did way back in section 3.8. That's negative 1. So now I'm plugging this in for the x. That's 2.1 minus 2 plus 1. So, oops, sorry about that. And let's see, that's 0.1, so negative 8 times 0.1 plus 1, that's negative 0.8 plus 1, which is 0.2. So k is approximately equal to 0.2. Tangent line approximation. Now, write an equation that can be solved to find the actual value of k. Well, that means we're just going to plug this stuff into our equation and try to solve for k. So let's see, that's going to be 2. I'm going back to the original equation now. It's 2.1 squared minus 2.1 times, that's the y value, k, plus k cubed plus 2.1 equals 9. And, well, this is, I don't know if you noticed this at the top, this is calculator allowed. So I think we're going to need our calculator to solve this. Let's just, well, you know what? We could clean it up a little bit, but really, why bother? We're trying to solve this for k, so let's go straight to our calculator. And let me get that where you can see the screen. Okay, that looks good. So I'm going to go ahead and try to graph that. Get that stuff out of there. So what do you mean graph this? I mean get everything on one side, so it's equal to 0, graph, and then find the zeros. That's how we solve equations like this. And there's no reason to do any simplifying. Minus 2.1, k will be, that's our unknown, so I'll make that x, plus a cubed plus 2.1, and then move the 9 to the other side, minus 9, and you know, if this offends you that there's all this unsimplified stuff, the calculator will do it for us. And then go ahead and graph, looking for the 0, the k value, and we know that it's supposed to be, that our approximation was not very good there. Did we do something wrong there? Oh, hey, guess what? We're doing part E now, I guess. This is write an equation that can be solved to find k, and then now we're actually solving it. So let's see. Second, calculate 0, and I'm not liking that this is so far away from our approximation. That is not making me very happy. So according to that, it's what, negative 1.782. But I'm going to go back and look at that again. I'm not really thrilled with that result. Let's just check it out real quick. Let's check our work. If I were you, I would be suspicious. Remember that College Board likes 3 decimal places rounded correctly. Let's just go back here and look real quick. So this was a point that was close to this. Let's check out our tangent line here, make sure that that's right. When we plugged in 2, 1 to get the slope, we did 1 minus 1 times the y value minus x. That does in fact give us, yeah, that's right. And that's the point. Y minus y equals slope times x minus x. So that is correct. And do we execute it correctly here? So then 2.1 is close to 2. So negative 8, 2.1 plus 1, negative 8 times 0.1. Okay, now we do this right. 2 times x squared minus x y plus y cubed plus x equals 9. Let me make sure I graphed that right. Is that what I put in there? So 2 times 2.1 squared minus 2.1 times k plus k cubed plus 2.1 minus 9. I cannot find anything wrong. But still, maybe you'll find a mistake, but certainly if this is our approximation and this is the value that we got, that is not a very good approximation, and this was pretty close, so I would certainly have expected it to be closer than that. So something is rotten here, but we'll figure it out. Anyway, good luck with those. Good night.